10.1 Pythagoras theorem in 2D and 3D shapes. What is Pythagoras theorem and how do we use it in two-dimensional and three-dimensional shapes? As success criteria, I know what Pythagoras theorem is. I can use Pythagoras to calculate unknown side lengths, and I can use Pythagoras in two-dimensional and three-dimensional shapes. So this shouldn't be too new to you guys. Pythagoras' theorem is stuff that you've covered in Year 9, Year 10 maths, possibly even as early as Year 8 maths. It's about finding the unknown side of a right angle triangle. So we have our triangle. I'm just going to make my page pretty and colourful. So I have a triangle ABC indicated by 1 point A, 1 point B, 1 point C. The other thing I'm going to do is I'm going to break this video up into two parts. So this is part 1. Let me just indicate that there. This is part 1, which is two-dimensional shapes. I went back through the examples and thought it was a little bit too long for one video. Let's break it up. So this little sign down in the corner here, this little square, indicates a right angle. You can't just assume an angle in a diagram is a right angle unless it is shown or you deduce it from other information. So unless they've told you it's a right angle or drawn this little picture in the corner, you can't assume it's a right angle. So we have our three sides, A, B, and C. I'm going to change colours because the green's not very dark there. That's better. So our formula that we're going to be using all through this is C squared equals A squared plus B squared. And from that, you need to have a C, an A, and a B. Now, the C is always the longest side, or the hypotenuse. The hypotenuse is the longest side of the triangle and is always opposite the right angle. So we found our right angle, we'll make our way out to the far side, and that's our hypotenuse. We call him C. Whether you put A in one side and B in the other, it doesn't make a difference. At the end of the day, you get the same value. Or you get the same solution, regardless of which way you went. So we have C squared equals A squared plus B squared. That implies that we are looking for C, the hypotenuse or the unknown side. But sometimes we might already have our C value. Instead, we'll be looking for our A value. So we rearrange or transform the formula so that C squared minus B squared is equal to A squared. Or perhaps we need to find our B value. So B squared equals C squared minus A squared. I'm transforming these now so that when you actually get to it and you don't have an A or a B value, but you have a C value, you don't freak out too much. You just plug it into the blue formulas here. So an exam hack. Jot this down. It often helps if you are aware of some of the common Pythagorean triples used in questions. These are groups of three whole numbers that satisfy Pythagoras' theorem and are often used as side lengths in questions. Some of the most common Pythagorean triples used are 3, 4, 5, 6, 8, 10, 5, 12, 13, and 9, 12, 15. Yeah, what the heck does all that mean? All right, let me draw a triangle. Here's my triangle, not drawn to scale, not drawn too neatly, but I have a right angle. Let's go 5, 12, 13. What this means is 5 squared plus 12 squared equals 13 squared. So one side is 5, one side is 12, and the hypotenuse is 13. Jot these down because if you see, for example, 13 and 5 in your, and have to find your unknown side, you're going to automatically know your unknown side is 12. All right, on to some examples. So, find the value of x correct to 2 decimal places in each right angled triangle. So it's indicated that it's a right angled triangle. It's also shown us the little right angle in the corner. First of all, we need to, I'll jot down our formula. C squared equals A squared plus B squared. And I'm going to jot down the transposed formula. A squared equals C squared minus B squared, or B squared equals C squared minus A squared. As I said, I've put down the transposed formula so you can look back and go, not going to freak out too much. I've already got it in the form of the unknown variable. again, or the unknown pronumeral, of which you learnt in algebra last term. So looking at part A, we have 8 millimetres, 11 millimetres, and unknown x. I found my right angle and I know the one opposite is my C value. My C value. Therefore, I'm going to be using the first formula of C squared equals A squared plus B squared. So, C squared equals A squared plus B squared. Then I substitute. It doesn't matter which I use as A or B. I'm going to call that one A. I'm going to call that one B. But it does matter which one is my C. So, x squared, that's my unknown value, is equal to 8 squared plus 11 squared. Now remember, 8 squared is, I'm going to pop this over the side, 8 squared is equal to 8 times 8, which is equal to 64. So that sign just means multiply by itself. 8 times 8 is 64. And then we add on 11 squared, which is 11 times 11, 121. And it's still worth x squared. We simplify that, x squared equals 185. Now, in order for me to get rid of that squared sign, I need to square root both sides. So x squared equals 185, and I'm going to square root both sides. My pen's a little bit touchy today. And I end up with x is equal to approximately, so a little squiggle on that top line, 13.6 millimetres. Now the question asks me for 2 correct decimal places. So I'm going to put 13.60. Remember to keep the units the same. I've got millimetres here, so my response must be millimetres there. The other thing to look for when you're trying to figure out whether your answer looks right is going, the longest value, which is my x value, should be longer, or the answer or the solution to it must be bigger than my A and my B. My A is 8, my B is 11, my x or my C value is 13.6. Yep, must be on the right track because it is bigger than 8 and 11. All right, changing colour for, let's make it a stronger colour. Changing colour for the next one so I don't mix up all my calculations. And I have 3 values again. I have a right angle symbol in the corner. And the one opposite that is, oh, it's 24, so that's my C value there. I've already got my C. I must have an unknown, let's call him A, and another side B. So my unknown A means I'm going to be using one of the transposed formulas. A squared equals C squared minus B squared. And we substitute in. A squared is also, my A value is also x. 24 squared is my C value, and my B squared value is 12 squared. X squared stays the same. 24 squared is 576, and from that I am subtracting, oops, my apologies, I'm subtracting 144. X squared, yep, you can use a calculator. I cheated and actually wrote all the answers or the calculations out earlier. And I ended up with 432. So again, like the previous one, I have a squared value and I need to find the x by itself. So I need to square root both sides. X squared equals 432. Let's square root both sides. And our x value, remembering that we're going to 2 decimal places, is 20.78. Now the unit that I'm using this time is centimetres. So I need to put my solution in centimetres. Double checking again, I have the longest side being 24 centimetres, and I know that my A value needs to be smaller than that. And I've got 20.78. Yep, smaller than 24, on the right track there. Part C is a square. See, I've got two sides that are the same value, x and x. And if I was to put a mirrored triangle like that, I would end up with x and x. I would end up with a square. So this is called a square triangle. All right, again, it's right angled and I have my C value, but I don't have my A or B value. I'm going to call this one A, I'm going to call that B. I have my C value, but what I'm going to do is I'm going to write out that first formula again. C squared equals A squared plus B squared. And then I'm going to substitute. So 30 squared equals x squared plus x squared. I didn't use the transposed formula because I'm now going to simplify from here. So 30 squared gives me 900, 30 times 30. And x squared plus x squared. One apple plus another apple gives you two apples. Therefore, I would have 2x squared. This is something we went through in, what's that magical thing we did last term? Algebra. That's it. We expanded, we simplified and whatnot. Adding two like terms becomes two of that like term. Now the next step in this, you don't jump to squaring yet. You want to get rid of this guy here. So in order to get rid of him, we divide both sides by 2. And we end up with 450 equals x squared. Then following the same concept and squaring both sides, our x value, so x squared equals 450, we need to square root both sides. Oh, I'm running out of room, and my x value is approximately 21.21 centimetres, remembering the unit that we used earlier. Still centimetres. So my x value, so that means that both this x here and this x here are both worth approximately 21.21 centimetres. All right, example number 2. Composite shapes. Calculate the value of x correct to 1 decimal place. So looking at this, I have a triangle and I have a rectangle. I have checked it is a rectangle, it's not a square. So I have 3 sides and I have a couple of unknown sides. First of all, I need to find my x value. And I know that with a rectangle, the length of one side is the same as the length of the other. Therefore, this is x. I'm going to get rid of those L's so it doesn't confuse people. But I know the length of one rectangle, let's color code it there. There we go. Is the same as that. All right, so far I have 2 sides of my triangle. I have a 12 and I have an x, but I don't know what this guy is down the bottom here. This question mark. I'm going to keep him as a question mark because he's going to actually have a value in a second. So I know that the length of the entire bottom composite shape is 15. I also know that from here to here, again following that same rectangle rule, so to speak, that both lengths are the same and both widths are the same, I know that that bottom line here, we'll colour that red, is the same as the top line here, which means it's 6 centimetres. And I then need to find out what, go one more colour, go light blue. I need to find this guy here. And I know that the entire length is 15 centimetres. So 15 centimetres, subtract 6 centimetres, gives me 9 centimetres. So my triangle, I'm going to draw him separately, is x, 12, and now I have a value of 9. Put my little right angle in the corner, and I need to solve for x. Pretty straightforward. Now remembering that this is opposite my hypotenuse, therefore it's my C. I'm going to call him A, I'm going to call him B. So using the transpose formula, A equals C squared minus B squared. My A is x squared is equal to 12 squared minus 9 squared. So x squared is equal to 144. Take away 9 nines are 81. So any of you that are actually following on, following in the textbook, I'm sitting on about page 166 of the Unit 2 text. And x squared is equal to 63. Then I square root both sides to get rid of the squared sign. So it looks repetitive, and it is repetitive, but the more you do it, the less you'll even think about it when you get the proper questions. So my x value is approximately, put my little squiggle there, it says 1 decimal place. So my answer would be 7.937, and because I'm rounding that to 1 decimal place, equals, 7.9, and we're working in centimetres. So that means my x value over here, 7.9 centimetres. A little less daunting when you actually break it up into step by step rather than, oh my gosh, I've got this composite shape. All right, last example that we're going to go through before I move on to part 2 of my second video. So example number 3. A rectangular gate has dimensions 3.8 by 1.8 metres. What is the length of a diagonal brace to the nearest centimetre? So, this is my gate. A couple of hinges. It's got a nice long brace through the middle. I'm going to put a red line there. This is what I need to find the length of, that brace there. I've got one side of my triangle there. I've got one side of my triangle there, and it is a right angle. It says rectangular gate. Now it doesn't stipulate right angle, but we know a rectangle has 4 right angled corners. So excuse my poor picture. That's my rectangle, and it has 4 right angled corners, implying that this gate has one as well. So let's move this picture off here so we're not confused by gate lines. Oops, wrong one. Disregard the fact that it's not straight. That's better. All right, so my first side is 1.8. My second side is 3.8. And I need to find the length of that. Now we're working in metres, but we need to find it in centimetres. It is easier at the moment to keep it as metres. You don't have to. You can work in centimetres and then convert it to centimetres now and go from there, or you can work in metres now and then convert it to centimetres later. My opinion, the metres are easier to deal with because the numbers aren't quite as big, and then we can convert it later, which is what I intend on doing. So I don't know this side here, which is the longest side. That's the diagonal brace. So I'm going to use the formula c squared equals a squared plus b squared. And I'm going to substitute in x, and I'm going to call this 1.8a. I'm going to square him, and I'm going to call my 3.8b. Now, the reason why I put brackets around these is so that nobody gets confused, and you know that the whole 1.8 is squared and the 3.8 is squared, and it's not just the decimal place that's squared. Okay, so x squared is equal to 1.8 squared, which is 3.24. And then I'm using a calculator on the side as well. And 3.8 squared is 14.44. X squared is equal to, let's add these together, equal to 17.68. At the moment, again, we're still in metres. Oops, I forgot my squared. And then we need to square root both sides. So x squared is equal to 17.68. And I'll change my colour. Square root that side, square root that side. And I end up with x is, approximately, because we're not going to get an exact answer, 4.20 meters. All right, but the question asks us in centimeters. So to get from centimeters to meters, I'm going to change colors. Centimeters, wrong way. Meters through to centimeters. We times it by 100. So 4.20 meters by 100 equals 420 centimeters. So this brace to the nearest centimeter has a length of 420 centimeters. That's a pretty big gate. All right, anything's there, and I'm going to go on to example 4, which is three-dimensional shapes, or examples 4 and 5, three-dimensional shapes, in my next video. Thanks.